In this video, you're going to get an introduction to the geologic time scale that we use in the Earth Science Reference Table. And throughout this time scale, it represents 4.6 billion years of Earth's history. And within that time scale, you'll even get an appearance from the dinosaurs, so stay tuned. But to start, the geologic time scale is simply a timeline that puts major geologic and evolutionary events in chronological order from present day all the way to the past when Earth began. If you go to pages 8 and 9 of your Earth Science Reference Table, you'll see this exact diagram which outlines the geologic history of New York State. Specifically, pages 8 and 9 of the reference table are designed to work together. So when you go to these pages, it's going to fold out in the very center of the reference table, and you need to look at both pages at the same time to answer questions. In this topic, we're only going to focus on page 8 of the reference table first, and the next lesson we'll learn how to incorporate page 9. So looking at page 8 of the reference table, the very first column that we need to understand is for an eon. Now there are two eons that represent this geologic time scale, and they take up the most time in Earth's history. Let's get a closer look by zooming in. So the units of measurement for this time scale are going to be millions of years ago. And at the top, you'll see 0 million years ago, which represents present day. And as you go to the bottom of the time scale, you'll see 4,600 million years ago, which represents the beginning of the Earth. Now we need to learn a little bit more about how this time scale is structured. So you'll see small bands closer to the top that are separated by 100 million years. So you have these black and white bands. So here's a white band, here's a black band, and individually, each of those bands represents 100 million years. Further down on the chart, you're going to see larger bands that are separated by 500 million years. So here's an example. We have a black band that represents 500 million years, and then also another white band that represents 500 million years. Now specifically, we need to be comfortable with reading these numerical values. So when you see the number 500, that means 500 million years ago. Not 500 years ago, 500 million years ago. Further down, when you see 2000, that's going to represent 2,000 million years ago, which is equivalent to 2 billion. Further down, we have 3,500 million years ago, which is equivalent to 3.5 billion. And then finally, at the bottom, we have 4,600 million years ago, which is equivalent to 4.6 billion years ago, which is the same as the age of the Earth. So our first eon that we're going to focus on is the one that's furthest in the past, which is the Precambrian eon. And that eon takes up the most time of Earth's history. Since it's so large, the Precambrian eon is broken up into two smaller eons. The one furthest in the past is the Archean eon, and then we have the Proterozoic eon. More recently, we have the Phanerozoic eon, which takes up a significantly less amount of time compared to the Precambrian, and it's the one that we are currently in. That's the eon that's part of our present day, the Phanerozoic eon. So now we need to take a closer look at these early eons and eras. And when I say early eons and eras, I'm talking about the ones that occurred first in Earth's history. These are the ones that are the furthest in the past. So specifically, we have that Precambrian eon that takes up the most amount of time. That's broken up into two smaller eons, the Archean and the Proterozoic. But now we have to look a little bit further to the right. And that brings us into a new column called an era. Eons are broken up into eras. And specifically, the Archean and Proterozoic eons are broken up into smaller eras to make everything a little bit more specific. So starting with the Archean, we have the early Archean, the middle Archean, and the late Archean. And then we have the early Proterozoic, the middle Proterozoic, and the late Proterozoic. So those terms, early, middle, and late, represent different eras. Now, if we look even further to the right, you're going to see important events that have happened during these early eons and eras. And we can use this time scale to pinpoint the name of those early eons and eras and even how long ago these events occurred. So let's look at an example question. What is the estimated age of Earth and the solar system? Well, if we look along those different key phrases, you're going to see at the bottom, estimated time of origin of Earth and the solar system. If we look over to the time scale, you'll see that this was 4,600 million years ago, and this took place during the early Archean, which was part of the Precambrian. Let's take a look at another example question. How long ago did oceanic oxygen begin to enter the atmosphere? So if we locate that on our time scale and we bring it over, we're going to see that this was 2,200 million years ago, and this was the early Proterozoic, which again is part of the Precambrian eon. Now, I want to focus on one more thing that's part of the Precambrian. So you'll notice on this page of the reference table that there is a portion that's colored in a light gray color. So I'm going to emphasize that right now with this green, just to show you where that is, because now we need to figure out how that part works with the reference table because it's a little complicated. So I need us to remember that again, our early eons and eras that make up the Precambrian take up a lot of time in Earth's history. And part of that gray section falls under that Precambrian part of the chart. So I want to draw your attention first to all the way at the bottom in this purple box where you see the phrase abundant stromatolites. You might be wondering, well, what is a stromatolite? Here's an image showing stromatolites that are part of our present day Earth, but these existed a really long time ago, specifically 1,300 million years ago. Stromatolites are just simply sedimentary rocks that contain organisms that have been dead, and specifically, if you remember cyanobacteria, the first organisms that we had on Earth, as those organisms die and settle to the bottom of water, they can start to form sedimentary rocks, and specifically, we have stromatolites. And stromatolites are really awesome because they provide evidence of really early fossils on Earth that shows evidence for early life in Earth's history. So what we need to realize is this gray part of the chart, you have to what we call follow the curve. So if we locate abundant stromatolites and we want to know which era and eon did this occur, in which era and eon were the stromatolites abundant, you take the spot in the reference table and you follow that curve over. And we know that this was 1,300 million years ago. And if we look, that goes through the middle Proterozoic of the Precambrian eon. So if you're asked to identify the era and eon that this occurred, you would just follow that curve along up until what we just did in this example. A little more recently, we had our first multicellular organisms that occurred 580 million years ago. And if you again want to find out during which era and eon this event occurred, you have to follow that curve over, and you'll see that this happened during the late Proterozoic, 580 million years ago.